Okay, we're going to look at an example of a matrix transformation that's based around an application. Okay, so I wanted to start by saying this is kind of a toy example. The numbers are not true to life, but this gives an idea of a kind of matrix transformation that we could build. Okay, so the life cycle of sea otters is that they are um, they're called pups for the first year, and um, and many pups die. So if you're a baby, you've only got a 25% chance of surviving to their first year. If you survive to your first year, you've got an 80% chance of surviving to your second year. If you've gotten to your second year, you've got a 90% chance of surviving to adulthood at 3 years of age. Okay. And when females reach year 3, they start having pups. And on average, mothers will have one female pup per year. So we're going to look at the number of female sea otters in a population. Okay, so we're going to look at vectors where the components are the number of pups, the number of first years, second years, and mothers in a population. Okay, and we're going to build a matrix that shows how this population changes over a year, called a transition matrix. Okay, so what this matrix is going to do is when we take an initial population distribution, so we know how many pups, first years, second years, and mothers we're starting out with. When we multiply it by this matrix, it's going to tell us after 1 year how many pups, first years, second years, and mothers will we see. Okay. All right, and we know to build a matrix that the columns are going to be determined by looking at A times 1, 0, 0. This will be our first column. A times 0, 1, 0, 0. Our second column, A times 0, 0, 1, 0. Our third column, and A times 0, 0, 0, 1. Our fourth column. So our goal is going to be to calculate these columns based off of the information that we're given. Okay, so for our first column, this is saying that we start off with an initial population where we have only pups and nothing else. So when we come back 1 year later, we expect that only 25% of the pups have survived. And it's 1 year later, so they've survived. They're now first years. So we have no pups. 1 year later, we see 25% of our original set of pups have survived. And we didn't have any first years, so there are no second years. We didn't have any second years, so there are no or mothers, and so we don't see any mothers. Okay. All right, for our second column, we're starting off with only first years. If we come back 1 year later, those 80% of our first years will have survived to become second years. So we will see no pups, no first years, only second years, and 80% of what we began with. In our third column, we're looking at what happens to second years. 90% of the second years are going to survive to become mothers. Okay, so we are looking at 1 year later. So our second years are now mothers. They're no longer second years. And there were no other populations around. And so all the other entries are zeros. Okay, finally, we've got our fourth column, which says what happens if we have one mother. What are we going to see next year? Okay. So mothers in the third year are going to start having one female pup a year. So what that means is we're going to, for one mother, we're going to see one pup. And the mother is still around, right? And so if we come back 1 year later, we're going to see a pup as well as the mother still there. Okay, and so we now have the columns of our matrix. We can form this matrix A, which is called the transition matrix. And if we multiply it by a population, it'll tell us how much we will see 1 year later. Okay. Okay. Let's take a look at an example of using this. So suppose that a storm blows a community of otters to a new region, and this storm moved 240 pups, 250 first years, 250 second years, and 200 mothers. We want to know what the population looks like after a year. And so here, the vector that we're going to be multiplying has these components of pups, first years, second years, and mothers. So 240, 250, 250, and 200. Okay. So we see our matrix A, and we're going to be multiplying it by our population distribution. 240, 250, 250, 200. So this is our initial population. And when we multiply this out, it's not too bad, but still going to, you can do this out on your own. We see that we have a population of 200 pups, 60 first years, 200 second years, and 425 mothers. So we computed this by calculating A times V. If we want to know what the population will be like in 2 years, what we can do is, well, 1 year later, we found by taking A times V. To find 2 years later, we can calculate A times V. Okay, so this says, how does the population change after 1 year? So this is our population 1 year later. We multiply by the matrix A, and that'll tell us, okay, now we've found what happened after 1 year. What's 1 year later after that? Okay. This is equal to A squared times V. So this composition that we're doing, where we say, look at how the population changes after 1 year, and then after 1 year again, we can calculate by doing a matrix multiplication. Okay. And okay, so this will be A times 200, 60, 200, 425. And it produces a population of 425, 50, 48, and 605. Alrighty, good job.